All right, good morning. It says Tuesday 3/5, but I think that's wrong. I think that should be Thursday 3/5, shouldn't it? Oh dear. There we go. Thursday 3/5, IB Math 5.3. Justification of the statistical techniques, part 3, and we'll be finishing up 5.3 today. So just one video today, a little bit longer with a couple of examples in it. Some things are a little bit familiar, but there's a difference. It's be doing something a little bit different. So looking at frequency tables and graphs from frequency tables, but a little bit different, not histograms. So something a little bit different here. All right, here we go. So really the topic I want to talk about is something called cumulative frequency. Cumulative frequency. And the idea here is that we're adding up a whole bunch of different times that something has happened and looking at some sort of things that have happened many, many, many times. So this is going to look a little bit familiar to our frequency tables, but a cumulative frequency table has one very important difference. We'll see it in a moment. So first, let's just do kind of a raw data frequency table. We're going to look at information, and I'm going to use the data so in case you kind of get stuck or lost or not sure where I'm getting the data from. The data I'm going to be using is from investigation number 8 on page 343. And it talks about data regarding the number of times that 50 different students have lost a pencil over the last month. How many times have you lost your pencil? How many times have you lost your pencil? So we're going to ask 50 different students. How many times have you lost your pencil? Now here comes the raw data. Now, I'm going to just write out all the raw data right here, but if you get stuck or a little bit behind, that's okay. Don't worry too much about the data. You can always go back and look at it from the textbook later. So the first person, I ask, how many times have you lost a pencil in the last month or the last week or something? And they say, oh, 5. I've lost 5 different pencils. And then the next person says, oh, I've lost 9. And then somebody says, oh, I've lost 10. And the next person says 5, and then someone says 9, the next person says 9, the next person says 8, the next person says 4, next person says 9, next person says 8, next person says 5, next person says 3, or 7 rather. The person of that, oh, I've only lost my pencil 3 times. 10 pencils I've lost, 7 pencils, 7 pencils, 8 pencils, 7 pencils, 6 pencils, 6 pencils, 9 pencils, 6 pencils, 4 pencils, 4 pencils, 10 pencils, 5, 6, 6, 3, 8, 7, 8, 3, 4, 6, another 6, 5 pencils, 7 pencils, 5 pencils, 4 pencils, 3 pencils, 5 pencils, 2, 4, 2, 8 pencils, 1 pencil, 0. Hey, I haven't lost any pencils at all. There we go. We knew there was at least one person. I don't lose pencils. I haven't lost any at all there. 3 pencils and then 5. And that should represent my 50 different people. So again, if you don't have all these numbers written down, don't get too crazy about this. It's really the frequency polygon or not polygon rather, the frequency distribution that I'm concerned about with this data. So I want to take a look at a frequency distribution. Now normally on a frequency distribution, we would take a look at the data and we would create classes. Like we notice that our smallest numbers are 0 and our biggest number looks like, let's see, there was a 10. Anybody lost more than 10? No. So I might do like 0 and 1, and 2 and 3, and 4 and 5, and 6 and 7, 8 and 9, 10 and 11, and then how many people in each one of those. And notice in those classes, any one of these would only be in one of those classes at a time. But this is a cumulative frequency, so it's going to look a little bit different. So here's what my data table is going to look like. So I'm going to look at the number of pencils that have been lost. And for my frequency, it's going to be the number of students who lost this many or less. Okay, so this is a cumulative frequency here. So my pencils, my numbers were 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I know I'm off the board here a little bit. I'll make sure I get there when I'm closer. So as I enter the number here, I ask myself, how many lost 0 or less? Well, only one person. How many lost 1 or less? Well, there was one that lost nothing, and there was one that lost only 1. So the cumulative frequency is 2. Now notice, this person that lost no pencils, they're recorded here as well. In our regularly frequency distribution, we never record the same person in more than one class. How many lost 2 or less? Well, there was one person here and one person here and 2 people here for a total of 4 lost 2 or less. How many lost 3 or less? Well, there was 1 here and 2 here and 4 here, plus another 5 that lost 3 for a total of 9. How many had 4 or less? Well, I take all of these 15 and I add 6 of them. I think it's 15 lost all that. How many lost 5 or less? 23. How many lost 6 or less? So I'm looking how many times did the number 6 or less occur? 30 times. 7 or less occurred 36 times. 8 or less 42 times. 9 times or less 47, and of course 10 or less 50, because there were 50 people all together. But notice, this person that lost nothing, they were recorded in every single one of these. So this is a cumulative frequency. Very important difference here. Cumulative frequency. How many lost this many or less for cumulative frequency? Now this is going to give us a very different chart. We would not use this to create a histogram because our classes here overlap. So the whole idea of a histogram is not going to work here. It's going to create a completely different diagram. All right, so let's take a look at the diagram and how to read the diagram and what the diagram tells us. And I'm going to use an example right out of the textbook. The one that I want to do, so this is a copy out of the page, out of the textbook. Oh gosh, that's a little dark. Let me see if I can make it a little bit brighter. Oh, I don't know if that's, I think we can do that a little bit better. This is on page 344, example number 10. And I just want to do this example right here. I want to look at this example. So if you've got your textbooks, go ahead and pull them out, and if you want to play along, I'm going to write all over this in a moment. Please don't write in your textbooks. Don't actually draw in your textbooks. On a test, you would actually have this diagram. You can write all over it. And in the homework, you would actually create this diagram, just like from the previous. I would take all my pencils, how many lost the pencils, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I would graph the points. For 0, there were one person. For 1, there was 2. For 2, there were 4. 3, there were 9. 4, there were 15, and so on, to create this diagram. Very different diagram here. So then we would create this diagram. Now let's take a look at it, and let's answer these questions. So this particular diagram talks about the cumulative frequency. Again, it's cumulative frequency graph representing the weight in grams of 80 different peaches picked from a particular tree. So 80 different peaches were picked from a tree. And how many weighed 10 grams or less? How many weighed 20 grams or less? 30 grams or less? 40 grams? 50 grams or less? 60, 70, 80, 90, 100, 110, 120, 130, 140, and then 150. The heaviest one must have been 150 or less. So you'll notice it's always going to get bigger and bigger and bigger. And you can see we've got some sort of, when we thought about this before in college algebra, this was logistic growth, population type of growth here. But this is actually a cumulative frequency polygon. All right, so now we're going to use it to analyze and answer some questions. Our first question here is, estimate the median weight of the peaches. The median weight of the peaches. Well, how many peaches were there? Well, this is the cumulative frequency from 0 to 80 peaches. There were 80 different peaches there. So what was the median weight? So the median weight, let's see, 80 divided by 2 is 40. So at 40, I'm going to use my ruler. I don't have a nice easy ruler here. I'm going to use this. And at 40, I'm going to draw a line at 40. Where's my highlighter? There it is. So I'm using 40. That's my median. That's my middle weight. I had between 0 and 80 peaches. 40 would be the middle. And then I'm going to draw my arrow straight down. And right about here, and it looks like somewhere between 100 and 110, 104-ish. I'm going to say about 104. So 104 grams. That's my answer. And of course, with IB, make sure we're always using our units. That's very important. Make sure we're using your units. Next, estimate the 40th percentile of the weight of the peaches. The 40th percentile. So how do I find the 40th percentile? So the 40th percentile, what is 40% of 80 peaches? Well, 40%, 0.4 times 8 is what, 32 peaches. So now I'm going to go to 32 peaches. So where's 32? 32 is right about here. I'm using 32 now. Again, I'm going to draw my line at 32. And straight down. And it looks right about there. Well, how much does that weigh? It looks a little less than 100, like 98 grams. And then finally, estimate the number of peaches that weigh more than 100 grams. How many weigh more than 100 grams? Now for this, I'm going to use my graph. I'm going to go the other way. Here's my weight. Here's 100 grams. How many weigh more than 100 grams? So if I go where 100 is and draw my line going up, and then going across 100 grams. Going across, it looks like, oh gosh, that looks, it's definitely between 32 and 40. I'm going to say that that number there is right around 34-ish. Okay, so how many weigh more than 100 grams? Well, 34. So 34 is the key number. 34 is a key number here, but 34 weigh less. How many weigh more? So if I said, well, how many weigh less than 100 grams? I would say 34. How many weigh more than 100 grams? Well, let's see, that's going to be 100 minus 34. So I'm going to say 46 peaches. And that's how we would create the cumulative frequency curve and then use it to answer different questions. A couple of hints out of the textbook. It says when you're dealing with group data, finding percentiles and quartiles as estimate is simplified by using cumulative frequency curves. Using these cumulative frequency curves can give me some really quick, good data. They're usually fairly easy. Outliers can kind of be harder to spot here. But just going across and back and forth by weight or by cumulative frequency. And again, don't miss this. The cumulative frequency, that many or less. Okay, so it's not just that many. All right, that's the only lesson, and now we're finished with 5.3. So go ahead and do homework 5H. And today, Thursday, I'm really hoping to be back with you next week. I was hoping to be back earlier this week, and for whatever reason, I guess I couldn't come back. I do have video lessons ready for next week as well, if need be, all the way up to spring break. But I'm really hoping to be back. And remember, well, let's see, today is Thursday. You should have done test corrections on that first part of that test right before class. So you should have enough time left in class right now to get 5H done and turned in. Get all those papers home to me. You should know by now I'm grading them, I'm entering them, recording them, and sending you grade checks. And hopefully everything's going pretty good, and I really hope to see you guys soon. I miss being in school. I hope to be back very soon. Bye.